Welcome to this video on the general equation of a parabola. Now, what does a parabola look like? Well, it looks something like this, okay? Where this has parametric equations, x equals a plus t squared, and y equals 2at. So I'll just pop those down now. So x equals a t squared and y equals 2at. Now for this particular one, a is a positive constant, and as a Cartesian equation it'd be y squared equals 4ax. As you can tell about the curve symmetrical, about the x-axis, and the general point is either xy or at squared and 2at. These two, values here. Now, a parabola is the locus of points where every point, if we call this point pxy, or at squared 2at, but it's every point on the parabola, so everywhere along here, where this point is the same distance from a fixed point, S, which we call the focus, and a fixed distance, like a straight line distance from a line called the directrix. So S is here, S is a comma 0, and then the directrix is over here, and this is the line or the equation x plus a equals 0, or x equals minus a. Okay, and it's the same distance, so this distance here is equal to this distance. I know it doesn't look like on my diagram, but this distance is equal to this distance, and that's the same for any point along this parabola. So basically the parabola has, if we call this point here where it hits the directrix as x, then SP is equal to px. They're the same distance. The focus, S, has coordinates a0. The directrix, so directrix, has equation x plus a equals 0, or x equals negative a, and the vertex of the parabola is at the point 0, 0. Now, in the real world, parabolas are very useful, and they basically focus light, sound, signals, used in satellite dishes, parabolic microphones, you may have heard of those, pick up sound from quite far away, and a few other things like solar power systems and stuff like that, for focusing the light of the sun and so on. So they are quite useful in real life. Obviously we're not going to worry about real life applications here on our FP1 course, but it's useful to know that they are actually really useful things. Now, in this video, we'll be looking at how you find the coordinates of the focus, equation of the directrix for a given parabola, or going the other way when you have the coordinates of the focus, the directrix, how do you find the equation of a parabola and stuff like that. So let's, well, actually, before we make a start with that, if you are new to my channel or you are a long time watcher but still unsubscribed, please hit that subscribe button now. And if you find this video useful at some point, hit that like button. Now let's get into a few examples. So starting off simple, find the equation of the parabola with focus 0, 5 and directrix x plus 5 equals 0. So first we start with the general equation. So y squared equals 4ax, and in this case a equals 5. So y squared equals 20x, and it's that simple. Let's have a look at another one. Okay, here we have another one. So again, same process. Start with the general equation. A is root 7 over 4. So 4 times root 7 over 4x. The 4's will cancel, so y squared equals root 7x. Now let's have a quick look at going in the other direction. Okay, so this time we've got the equation of the parabola and we need to find the coordinates of the focus and the equation for the directrix. So again, I'll pop this equation up and then I'll pop the general equation up. So, 4a equals that 32. So a equals 8. So the focus is 8, 0, and the directrix is x plus 8 equals 0, or x equals negative 8. We'll have a quick look at a second one. Okay, this one is y squared equals square root of 128 x. So this is root 128 is 8 root 2. And compare that with the 4ax, then 4a equals 8 root 2. Divide by 4 and we get a is 2 root 2. So the focus is 2 root 2, 0. And the directrix is x plus 2 root 2 equals 0. Or x equals negative 2 root 2. Now, sometimes you have to find the equation of a parabola, but you have to show it rather than just state it as we've done in these examples. So here is one of those types of problems. A point x, y, so p, obeys a rule such that the distance of p to the point 5, 0 is the same as the distance of p to the straight line x equals negative 5. Show that the locus of P has an equation of the form y squared equals 4ax, starting with the value of a. So now we can't just state that a is 5. Okay, we've got to show that. So first I'll just do a little sketch. So we've got a parabola, we've got the line x equals negative 5, we've got the point S, which is 5, 0, the point P P, which is x, y. So we've got that line and we've got that line. Obviously on my sketch they look completely wrong, but it is just for illustration. Okay, now this length, well, this distance here is 5 because x is minus 5 here. This is 0. So this distance here is 5. And then this distance is x because the coordinates is x, y. So that distance is x. Now this distance is a diagonal distance, and we call this distance d, and that we're going to use Pythagoras to find the distance between two coordinates. So, you know, x1 or x2 minus x1 squared plus y2 minus y1 squared. Okay, so that's what we're going to look at for that. Now we know that those two distances are equal. It says within the question, you know, up here. So we can say that d is equal to 5 plus x. Okay, so I can basically start off with, you know, d equals 5 plus x, or d squared equals 5 plus x squared. Now, why am I using d squared? Well, quite simple. If d equals x2 minus x1 plus y2 minus y1, these are squared and then square rooted, then d squared equals x2 minus x1 squared plus y2 minus y1 squared. And I haven't got the square root, so it's easier to deal with. Okay, now in this case, x2 can be my x and y. So x minus and y minus. And my x1 and y1 can be the 5, 0. So that will be 5 and that will be 0. So that's what I'm going to substitute in to here. So x minus 5 squared plus y squared equals 5 plus x squared. Now I'll expand it. So x minus 5 squared is x squared minus 10x plus 25. And 5 plus x squared is 25 plus 10x plus x squared. Now, the x squareds will cancel. The 25s will cancel. So I've got y squared, taking the negative 10x to the other side. We'll add it on, giving me 20x. So y squared equals 20x. Now this is the form. Y squared equals 4ax. So this equals 4ax. So 4a equals 20, a equals 5. And there we have it. We have shown that it is in the form of y squared equals 4ax here, and we found the value of a. Okay, so that's how you go about showing it. So when it's a show that, you can't just jump straight in and just state. You actually have to show it. Now, this isn't the full video at the moment. So what we're going to do here is we're just going to do a couple of questions on this. And then don't go away, because after I've gone through the answers to those, we're going to carry on with the parabola. So here are 3 questions for you to try yourself. Pause the video, when you feel like it soon to try them. I'll put the answers after these, and then stay tuned then, because we've got some more examples to do with the general equation of a parabola. Okay, answer to this is quite simple. A equals 9 and y equals 4a, y squared equals 4ax. So y squared equals 4 times 9 times x, which is 36x. Y squared equals 50x, and y squared equals 4ax. So 4a equals 50, a equals 12.5 or 25 over 2. So the coordinates are 25 over 2, 0 for S, the focus, and the directrix is x plus 25 over 2 equals 0. Now this one is a good idea to draw a sketch, and the reason for the sketch is not only it makes it obvious what you're doing, but when you put values or letters onto the sketch, then it makes it obvious. So what I mean by that is we've got this point P, X, Y. That's the distance D, and that's the distance x plus 7. So now I can use D and x plus 7 within my equation. So D squared equals x plus, D equals x plus 7. D squared equals x plus 7 squared. And D squared is x minus 7 squared plus y minus 0 squared. Now that's x squared minus 14x plus 49 plus y squared, and this is x squared plus 14x plus 49. The 49s will cancel, the x squareds will cancel, y squared equals 28x, where 4a equals 28, so a equals 7. Okay, and there I've got that question done. So hopefully the beginning of this video is quite straightforward. Now we're going to look at just a slightly harder example, so stay tuned. Now, if you are enjoying the video so far, don't forget to hit a like, subscribe if you haven't subscribed already, and if you feel like giving me a little bit back financially, consider joining as a member. You can join for 1 month or more than 1 month. It's very, very, very cheap. Okay, it just gives me a little bit. So yeah, there's that. Right, let's get into this next example. So here we have the next example. It's quite big. It's broken down into many parts, but we've got a parabola C with parametric equations x equals 6t squared and y equals 12t. The focus is the point S. So the first step here is to find a Cartesian equation of C. So just made a little bit of room, but we've got x equals 6t squared and we have y equals 12t. Now it's easier to change the y1, so t equals y over 12, and to substitute that into the x, so 6 times y over 12 squared. So it's 6 times y squared over 144. And then 6 is going to go into that 144 24 times. So that will be 24y squared. So y squared equals 1 over 24x. And that is the Cartesian equation of C. No, sorry, that is a mistake. Because this is 6 divided by 144. So it's 24 on the bottom. So y squared equals 24x. Okay, so sorry about that. A little silly mistake from me there. So y equals 24x. Y squared equals 24x even. Right, let's get on to part B. So part B is state the coordinates of S and the equation of the directrix. So we know that 4a equals 24, so a equals 6. Therefore the focus S is the coordinate 6, 0. And then the directrix is x plus 6 equals 0. Now, part C is sketch the graph of C. So, obviously use a ruler for your axes, although it is just a sketch. It's going to look, make sure it hits that 0, 0. So S here is 6, 0. And then this line is x plus 6 equals 0, and this is obviously C. Okay, so that's all there is to that. Now part D here, state the distance PS. Well, P is obviously up here, that is the point P. It's that distance there. Now we know it's the same as like px, for example, and it says up here the points P and Q on the parabola are both at a distance of 9 units away from the directrix. So if this is 9, this is 9. So PS equals 9 units. As simple as that. Now, next we have to find the exact distance PQ. So Q, say, is down here somewhere, because it's got to have the exact coordinates 9. Well, it could be anywhere on this axis, on this parabola. No, sorry, it couldn't be anywhere on the parabola. The definition of the parabola is that this distance always equals this distance, but when you're closer, it's a shorter distance than when you're further away. So Q would have to be basically symmetrical, so straight underneath P, for this distance and this distance to both be 9. So Q would have to have basically the same x and a minus y for its x and y coordinates, whereas P then would be our x and y. So we'll deal with SP first. So SP equals 9, and P is the coordinates x, y. And if you remember, y squared equals 24x. So P is the coordinates x and root 24x. Sorry, the root goes over the x as well, doesn't it? So 24x, the square root of all of it. Okay, so then this distance, SP, we can also call, as D. It's 9. But D squared is equal to x2 minus x1 squared plus y2 minus y1 squared. Okay, where my x2 and y2 will be P, and my x1 and y1 will be S. So the D squared is also 9, so 9 squared. And then I've got x minus 6 squared plus, and then the y2 will be 24x, root 24x minus 0 squared. So this is 81, and then we've got x squared minus 12x plus 36 plus 24x. So that's x squared plus 12x minus 45. Now, if I use my calculator, it will tell me that x equals 3 and x equals negative 15. Now I can take a step back from that, so that'll be x minus 3, x plus 15. So that is that factorised, but I use my calculator to essentially cheat. So we've got two possible answers, but only one of them is correct. We can't have the negative x, because that will be over this side. It's the positive x. Therefore, x equals 3. So P is 3, comma. Now 24x is 24 times 3, so 72. Square root of 72 is 6 root 2. So P is 3, comma 6 root 2, which means that Q is 3, comma minus 6 root 2. So we've got our P and our Q. So the length of PQ is 12 root 2. Then the final step, PQS, so it's this triangle here, PQS, so that straight line there. So PQ will be the base of the triangle, and the height will be the difference. Oh yeah, this is 3, so it's actually this side. So this diagram is actually a little bit wrong. If I just rub out there, the S is actually over here somewhere. So PQ is down there, S is like that. So that's at 3. So the height of this triangle is 3, because it's between 3 and 6. The base is 12 root 2. So it's nice and straightforward. So area equals a half times base times height. So that is 6 root 2 times 3, 18 root 2. And there we come to the end of this problem. So I'm going to give you one similar one with quite a few little bits to do. So stay tuned. So here's the final question. Question 4. Pause the video now, have a go, and then I'll put the answer afterwards. So first part is find the coordinates of S. So y squared equals 4ax. So 4a equals 4a equals 1. So S is 1, 0. Now the point P with y coordinate 4 lies on C. Find the x coordinate. So if y is 4, we've got y squared equals 4x. So that is 4 squared equals 4x. 16 equals 4x. X equals 4. So P is the point 4, 4. Now, the line L passes through S and P. Find the equation of the line L in the form ax plus by plus c equals 0. So we can do this in two different ways. The way I prefer is to find the gradient first. So this is y2 minus y1 over x2 minus x1. So it's 4 over 3. And then to use y minus y1 equals mx minus x1. And I'll use the s coordinate. So y minus 0 equals 4 thirds x minus 1. Now, since I want it in this form where they're integers, I need to multiply it by the 3. So that is 3y, and then 4 times x and 4 times negative 1 is 4x minus 4. And then take everything to the x side, 4x minus 3y minus 4. And then it's in this form. You could obviously take everything to the y side, but since we start with x in this form, I prefer x to be positive. So I always take it to the side that x is positive. That's just my personal preference. You could equally take everything to the left-hand side. Now, part D, the line L meets C at point Q. Find the coordinates of point Q. So we need to equate y squared equals 4x and 4x minus 3y minus 4 equals 0. So this is quite straightforward because look, 4x and 4x. So I can swap the 4x here for y squared. So this becomes y squared minus 3y minus 4 equals 0 when I equate them. So it's y, and multiply to give me 4 is 4 and 1, and add to give me minus 3. So it's minus and a plus. So y equals 4, y equals negative 1. Now, we've already dealt with the y equals 4. That was point P. Therefore, Q is y equals 1. So now when y equals 1, so let's go into the y squared equals 4x. So that's 1 squared equals 4x, x equals 1/4. So q is 1/4, minus 1. That was minus 1 squared. Same thing there, yeah? So 1/4 minus 1. Now, part E says find the distance of the directrix of C to the point Q. So the directrix of C is the point X of the line X plus 1 equals 0, and Q is 1/4 minus 1. So the distance is going to be, so this is x equals minus 1, isn't it? So the distance is 1 and 1/4, or 5/4. Okay, it's quite straightforward, but you know, if you've got your line here at x equals minus 1, and the x coordinate of Q is 1/4. You know, it's obviously down here 1/4 minus 1, but it's this distance, yeah? It's always going to be the shortest distance, this horizontal distance here. So it's 1 plus 1/4. Okay, so 5/4. And that is it, the end of the video. So just to remind you again, subscribe if you haven't done so already. Hit that subscribe button now. Smash a like if you found this video useful. And if you are willing, able to, inclined to give a little bit back to me financially, then hit that join button. It's very, very cheap. You can join for 1 month, 2 months, whatever. I don't mind. I don't mind if you don't join. But if you want to help me out, give a little bit back, then please hit that join button now.